Let's now figure out what the density of water is. I actually have a jug of distilled water that's been sitting in the classroom for a long, long time. So it's at room temperature. And I'm going to put it in this flask to measure its volume. So obviously you can't use a vernier caliper to measure the volume of water. So you use flasks that are meant for liquid measurements. And this doesn't have any gradations in it, but it does say something on it. It says 100 milliliters, let's see, plus or minus 0.08 milliliters. So if you fill this flask up to that white line, you will have exactly 100 milliliters plus or minus 0.08 milliliters. So 0.08 millimeters is the precision of this flask. So first of all, what we want to do is find out what its mass is empty. So this is a dry cylinder. Its mass is 68.4 grams. So what is that in terms of kilograms? Move the decimal place over to the left 3 ways. So that's 0.0684 plus or minus 0.0001 kilograms. So again, make sure you write the precisions down correctly. It's 68.4 plus or minus 0.1 grams, or 0.0684 plus or minus 0.0001 kilograms. So that's the mass of the empty flask. So what we're going to do now is put water in our flask. So I'm going to take it down off here, and let's fill it up with water to the white line. So I've put some of my water in this beaker, and here we go. Let's fill it up. Try not to get any on the outside. If I do, I have to wipe it off because it'll add to the mass. So I want to find the mass of 100 grams of water. I'm going to get it close to the white line. Okay, so let's actually what we want to do is make sure that the two white lines in the back and the front line up, and the meniscus is on top of that white line. So as you can see, the meniscus is a little bit below that white line. So I'm going to hold the iPad here. I need to move the meniscus up so that it's right at the bottom of the meniscus is at the where that white line is. Okay, that looks really close. Okay, that looks pretty good. So what we're going to do is mass this. Here's our first mass trial with the water and the flasks. 168.0 grams. So 0.1680 plus or minus 0.0001 kilograms. So what I'm going to do is dump this out and then refill it. So we're going to do 3 different trials. You can see that it takes a little bit of experimental. I probably didn't have to dump the whole thing out. I really only had to dump a tiny bit out. Now I have to fill the whole thing up again. It's just the matter of trying to get the meniscus thing correct. We want to do it several times just to make sure I didn't make mistakes. There are some errors that you can make in figuring out approximately where the meniscus is. So I shouldn't have dumped the entire, I could have just dumped a tiny bit out and then refilled it a little bit to where the meniscus is. And here comes the water. Up. Okay. So again, let's readjust. So we're a little bit below. I'm trying to match the white lines here. I'm trying to go with this black background so that it's really, the light is really bright. That's much better. All right. So where are the white lines? Okay, so it's below the white lines. You can see it's below the white lines. So what I have to do is put a couple more drops in. It still looks like it's a little bit below. Oh, one more drop. Did I put the drop in? There we go. Oh, that's pretty good. All right, so we remass it. Oh, I guess my thing turned off. Let's let it go through its calibration again. It times out. I can't change that. If you don't like do anything to it for a couple of minutes, it'll just. All right, 168.1 grams. Okay, again, that's 0.1681 plus or minus 0.0001 kilograms. So what I'm going to do is take a little bit off of this and then refill it. So now it's below. So we're going to refill it until I get up to the white line. And I'm just going to do this offline because it's just faster for me to do this. All right, there you go. Okay, and then I get 168.1 again. All right. So again, they're very similar to one another. So I have my three measurements. Two of them is 168.1, one of them is 168.0. So now that we have the masses of the filled ones, what you're going to do is subtract off 100 milliliters off each of those. Find the average of those masses, subtract off 100 grams, and you have the mass of the water. I'm sorry, you don't subtract off 100 grams. You subtract the mass of the empty flask. So the mass of the empty flask is 68.4 grams. So you take, average out the masses, subtract off 68.4 grams, and then you'll find the mass of the water, which should be around 100 grams. You can see it's 100, it's about 100 grams. Then divide that by the volume, which is 100 milliliters. Now 100 milliliters is also a cubic centimeter. So if you want to convert it to liters, you can. There's several ways to do this measurement, MKS or CGS. If you keep everything in grams, you will have grams per cubic centimeter, which is a very common unit to use. If you convert to MKS system, you will have kilograms per cubic meter. So to do that, you're going to have to take 100 milliliters and change it into cubic meters. It's not hard, you just use multiplication factor. So in either way, CGS or MKS, you must either do CGS systems or MKS systems. You can't mix grams with cubic meters, and you cannot mix kilograms with cubic centimeters. It doesn't work out that way. And then what you do is you compare that with what it's supposed to be, the temperature, the room temperature in the room. So what is the room temperature in the room? That's one last thing we have to do. Let me just get a thermometer here. So room temperature, I am going to take using this thermocouple. So this is a thermometer. And what is this thermometer? It has a little metal tip on it. And you can see that when I put my hand on it, the thermometer goes up because it's heating up. So now let's go back to room temperature, of course. Now it's going to take a while for it to go back to room temperature. I can dip it in water and I can get, there you go. So I just dipped my thermometer in the water so I can get the temperature of the water really quick. It's 22.6 degrees Celsius. Okay, 22.6 degrees Celsius. That's the temperature of the water. Go online and find the density of water at 22.6 degrees Celsius, and then compare your experimental result with what it's supposed to be.